So in this video, we are going to see the solution part of this problem, that is reorder list. So initial linked list that has been provided to us is somewhat like this, where L1 point towards L2 and so on till Ln. Now we need to reorder this in such a fashion where L1 points towards the last node, that is L9. This last node points towards the L2. L2 points towards L8. L8 points towards L3. L3 points towards L7. L7 points towards L4. L4 points towards L6, and L6 points towards L5. So we need to reorder our linked list in such a fashion. Now what we will do is, how we are going to convert this linked list to this one. Okay, so let's keep this aside. So what we are going to do is, here first we will find the midpoint of the linked list Okay, so this we are going to do with the same approach that we have used earlier, slow and the fast pointer. Okay, so with the help of this, we are going to find the midpoint of the linked list. Now, with the help of this linked list, we will divide our linked list into two parts, the second half and the first half. Okay, so this will be second half and this will be the first half. Okay, so the head of the second half will be nothing but midpoint dot next. Okay, midpoint dot next will be the head of the second half. After getting the head, we will erase this link. Okay, so that we will get the second half of our linked list. Now what we will do, we will reverse our second half. So let me take this much. So we are going to reverse the second half, so that now this L9 will point towards L8, L8 will point towards L7, L7 will point towards L6. Okay, this will be our reversed second half. Okay, now what we are going to do is, see here L1 is pointing towards L9, so we need to generate a link between these two. So how we are going to do that, we are going to create some pointers here. So let me create some pointers, F1, F2, K1 and K2. So F1 will point towards the head, basically the starting node. So it will be pointing towards the head of the first half, which is head only. F2 will point towards the head of the reversed second half. So for the time being, let us call it head 2. So it will point towards the head 2. K1 will be this one. So K1 will be nothing but F1 dot next, and K2 will be nothing but F2 dot next. Okay, so why we are creating this thing now? It will help us to create the links. Okay, so let us write it somewhere. So let me write here F1, this is going to be F2. Now K1 is F1 dot next, so this will be K1 and this will be K2. Okay, so let me erase this thing, erase all these things here. Let me minimize this thing. Okay, let's see what we are going to do. First, we need to generate a link between L1 and L9. So what we will do, F1 dot next is equal to F2. So this will get erased and a new link will be established between L1 and L9. Now L9 points towards L2, that is here. So we will establish a link here and remove the previous one. So for that, what we need to write that F2 dot next is equal to F2 dot next is equal to K1 here. Okay, it will be K1. Now we will increment, not increment, we will make F1 as K1 and F2 as K2. So F1 is equal to K1 and F2 is equal to K2. Okay, and till what time we are going to do this thing is till our second half is not equal to null. So why our second half is not equal to null, is not equal to null, we are going to make, we will remove the previous links and create new links so that we can get a reordered list. So now let's see what happens. So now this is our F1, this is our F2, and K1 will become F1 dot next. So here is our K1 and here is our K2. Okay, now again F1 dot next is equal to F2. So we will remove this link and F1 dot next we will form a link here equal to F2 and F2 dot next is equal to K1. We will again form a link here and remove the previous one. After that we will make this as F1, this as F2, and again K1 will be F1 dot next. So here comes our K1 and K2. Keep a check on this while condition. Since our second half is not equal to null, we move forward. Okay, now again F1 dot next is equal to F2. We will create a link here. F2 dot next is equal to K1. We'll create a link here and we will remove the previous links. After that, we will move forward. We will make this K1 as F1, K2 as F2, F2. Okay, and K1 is equal to F1 dot next. So here comes our K1, and K2 is equal to F2 dot next. So since there is nothing, therefore K2 will now point towards null. Okay. Now again the same things. F1 dot next is equal to F2. So there will be a link between L4 and L6, and F2 dot next is equal to K1. So there will be a link here, and we will remove this earlier links. Okay. Now our F1 will point towards L5 and F2 will point towards null. So here the second half is equal to null, so therefore will come out of the loop. Now let's see that what this this link is forming for us. So if I erase all these things, we are getting L1 pointing towards L9, pointing towards L2, pointing towards L8, L3, L7, L4, L6, and L5. So this is our reordered list, which is same as that we designed. So that was it for the solution. Now we will code this problem. Thank you. So now we will write the code for this problem. So in order to solve this problem, we require two other functions. First one is to find the midpoint of a linked list, and the second one is to reverse the linked list. So that I have discussed in the palindrome linked list problem in detail, so you can check that out. Here I will just write the code. Okay. So public list node, we are going to create a midpoint list node head. Okay, so the base cases are that if it is is equal to null, or head dot next is equal to null, then we are going to return head. So if only one node is present in our linked list, so that will be the midpoint only, so we are going to return that only. So that was for the base case. Now, so in order to find the midpoint, we required two pointers. First one will be the small and the second one will be the fast. Fast will have twice that of the speed of the slope pointer. So what we are going to do here is that list node slope, which will be initially pointing towards the head, and the fast, which will be also pointing towards the head. Now, while fast dot next is not equal to null, and fast dot next, because it is moving twice in every step. So fast dot next is not equal to null. What we are going to do is we will make our slow pointers to move a single node, that is slow dot next, and fast will move two nodes, that is fast dot next. Okay. And when this condition will satisfy, our slow pointer will be pointing towards the midpoint of our linked list. Okay, so return slow. So that was for the midpoint. Now we will write the code for reversal. List node, name it as reversal. It will also take head as a parameter. Okay, so the base case will be same, that if only one element we have, only one node we have, so in reversal also it will be same. So we are going to copy the base case here and we will paste it here. Okay, so now in order to reverse our linked list, we require three pointers, that is list node previous, which will be nothing but null, list node current, which will be pointing towards the head, and one more list node forward. Okay, so while our current is not equal to null, what we are going to do is, so for this I will explain you a little bit because it will become absurd. Okay, so let me take another sheet here. So suppose we have a linked list that is containing 1, 2, 3, 4 and 5. Okay, so 1, 2, 3, 4, 5 it has, and we need to reverse it. So we will create three pointers. First one will be the previous, which will be pointing towards null, then a forward pointer, and then a forward pointer, and a current pointer, which will be pointing towards the head. Okay, so we will make forward pointer to point towards the current dot next. So here comes the forward. Okay, now we will break this link and we will make current to point towards the previous. So this. Okay, now we will make current as our previous and forward as our current. Okay, so again we will do the same thing. We will make forward as current dot next. Forward will come here, and we will make current dot next as previous. So current dot next will become previous, so this link will get broken, and here it will come, and again my previous my current will become previous and forward will become current. Okay, and forward will come here. So this process will go on till the current is not equal to null, and at last my previous will be pointing towards the uh, head of the reversed second half. Okay, so same I am going to write here. Okay, so while current is not equal to null, what I will do is forward will be current dot next. Okay, forward will be current dot next. Current dot next will be previous. Current dot next will be previous. Previous will be current. Current will be forward. Current will be forward, and we will return previous as our, as the head of our reversed second half. Now in the reorder list node, what we are going to do, so first we will write the base conditions, that if head is equal to null, or head dot next is equal to null, what we are going to do, we are going to return return so return nothing. Okay, just leave it here. Now first we need to find the midpoint, so we will create list node mid, and we will call our function that is midpoint. And we will pass the head in that. Okay, now we need to create the we need to get the head of the second half. Therefore list node second half will be nothing but mid dot next. And we will break the link, so mid dot next will become null here. Okay, so if we go on the board, this one, so till now we have found out the midpoint and the head of the second half, and we have broken the link between the midpoint and the second half. So my second half, we have found out the second half, we have broken the link between the second half and the midpoint, and now we are going to reverse our second half. Okay, that we need to do here. Okay, so second half will be nothing but reversal, and we will be giving it second half as a parameter. Okay, now list node first first half is nothing but the head. Okay, and we will create some pointers here. Okay, so list node f1 will be head only, list node f2 will be the head of the second half. Okay, so it will be second half only, second half, and list node k1 will be null initially, and list node k2 will also be null. So we have created some pointers. Now while our second half is not equal to null, second half, or instead of second half we can write that if f2 is not equal to null, what we are going to do. So let's check. While our second half was not equal to null, what we were doing f1 dot next, we were connecting it to f2, and f2 dot next we were connecting it with k1, and then moving the f1 and f2 pointers. We will do the same thing here, that f1 dot next is equal to f2. Okay, and f2 dot next is equal to k1, and f1 is equal to k1, and then f2 is equal to k2. Before that we have not given k1 and k2 any value, so k1 will be nothing but f1 dot next, and k2 will be nothing but f2 dot next. Okay, f1 is equal to k1 and f2 is equal to k2. So I think it's good only, so we will run this thing. So it is getting accepted. We will submit this thing. So it is getting submitted also.